Next speaker in the queue is Dr. Li-Ming with NOAA Fisheries, maybe with NIPS too.
Okay, good. Thank you, Sam. Why it's not focused? Which one's focus?
Oh, focus.
Focus, yeah.
I don't know if you control it.
Focus.
Oh. Okay, thank you, the panel, and good morning, everyone. I'm Li-Ming. I work for NOAA Fisheries West Coast Region, California Central Valley office here in Sacramento. So today I'm going to present you some scientific information about how interior delta flows impacts NOAA Fisheries USA listed species. So we have 4 listed species in the Central Valley and in the Delta that might be impacted by delta flows. First listed species is endangered Sacramento River winter-round Chinook salmon. Second listed species is the threatened Central Valley spring-round Chinook salmon. The third one is threatened California Central Valley steelhead. And the last one is southern distinct population segment of North American green sturgeon. This is a long name. This species is also threatened as listed. But today I'm going to focus the first 3 salmon species because we do not have many data available for green sturgeon. So NOAA Fisheries, we had many RPA actions for protecting juvenile fish that migrate from upstream through the delta. Here I just give you a brief summary, but I'm not going to give you details here. So the first element is DCC, delta cross channel. DCC gates. The trigger would be the number of fish migrating downstream from North Landing, Nice Landing, or Sherwood Harbor. That those 2 locations have monitoring stations to monitor juvenile fish coming down from Sacramento River. When certain trigger, means a certain number of fish reach it, and then the gates will be closed. That's upstream. And the next one is in South Delta. We have 2 elements. So first one is OMR flow. That's here. If certain number of fish reach it, and then OMR flow will be made to less negative. That means reverse flow will be reduced. And the last action or element is water export. We also use the fish number that is salvaged to those 2 fish facilities in South Delta, 2 fish facilities here. If a certain number of fish is reached, and then we have to reduce water exports. So 3 elements and a bunch of actions. Now, how do we do this? what kind of scientific support we have to have those actions there. I think the first one is large quantities of juvenile fish entrained to world export facilities. The second one is that juvenile fish entrainment is correlated to world export or OMR flow. That's second. And the last one, in general, juvenile fish survival is lower in entrainment routes. So for the next 15 or so slides, I'm going to show you the scientific support or evidence to elaborate each of these three conclusions. First, I will give you one conceptual model for Delta salmonids juvenile survival. Well, this is complicated, but I'm not going to show you the details here, give you details, but very briefly, there are many, many layers of drivers, stressors, and different effects also to individual and to population. And then certainly the water export and the flow, just two of those impacts or factors. But today I'm going to focus delta flow, particularly interior delta flow, because this workshop is particularly for that. And this model actually was generated by South Delta Salmon Research Collaboration. There is a report available. Now here I'm going to give you a brief introduction about the delta. So when we talk about the delta, then you can see this North Delta, this area, and the South Delta. And then there's a major rivers, the Sacramento River, also San Joaquin River running from south to north, and the Chips Island. Usually we use Chips Island as an endpoint when we talk about survival. And then last one is water export facilities, because water export does impact fish survival, which I will talk about in detail. So in general, fish or water flow from Sacramento River, they can run into from North Delta to Chips Island through main channel of Sacramento River. And then next one is water of fish, juvenile fish, can run from Sacramento River and directly to from North Delta to South Delta and to water export facilities. Water from San Joaquin River or fish from San Joaquin River can go through the main channel of San Joaquin River. And the last major route was the fish or water from San Joaquin River can go through Old River and get into interior South Delta and go to water export facilities. Now let's talk a little bit about the North Delta water flow. So that one is Sacramento River, and then you can see Georgiana Slough. And the Georgiana Slough, you can have water going through to Sacramento River, to San Joaquin River. And then next two channels are Lower McClomie River. And those water actually can also go from north to south and get into San Joaquin River. Now what we are interested here is North Delta, that area, because the two channels, One is the DCC, Delta Cross Channel, that controls water flow from North Delta to South Delta. Also, the Georgiana Slough, that also controls water flow from North Delta to South Delta. Now, South Delta water flow is more complex than North Delta. So, San Joaquin River flow from south to north, and then you have a tributary, it's called the Older River, that also discharges water into South Delta. And then you have different cuts or channels from San Joaquin River. And when water export is going, and then you have reverse flow from all those cuts and channels, and then converge to Old River or Middle River, and then finally goes to water export facilities. So all those routes would impact fish travel or fish migrate, either from Sacramento River or from San Joaquin River. So first, as I said, there is a large quantity of Chinook juvenile entrainment toward export facilities. So I'm going to show you a few examples. So first is a winter-run Chinook salmon and a spring-run Chinook salmon. That's salvage data from both export facilities. And then those fish actually, winter-run and spring-run Chinook salmon are exclusively from Sacramento River, as those fish are drawn to state or federal water export facilities. Here, I just point out here, when you look at this data here, those view graphs, in recent years, the salvage data shows the salvage in recent years are below average for both winter run and for spring run. Now for steelhead, same, but it's kind of different. So 90% of steelhead juveniles were coming from Sacramento River, as shown here, and only 10% of steelhead juveniles are from San Joaquin River. But both of those fish, either from Sacramento River or San Joaquin River, can go to water export facilities. Here's a graph shows each year how many steelhead juveniles were salvaged by those two fish facilities. Again, the average in recent years were lower than previous years. And number two, I said juvenile winter run or juvenile spring run and steelhead were correlated to water export. So that means you can see those graphs for CVP, water export, SWP, water export. This is the month, February and March. The y-axis is daily CVP salvage. And here is daily CVP water export or SWP water export. Now I need to point out those blue lines are just trends. It's not really telling how significant they are. And here also I used a regression through the origin. That means the regression without intercept. The intercept is forced to zero.
Li-Ming, can I stop you for a second?
Yes.
I had a couple questions came up. What are the statistical significance of those lines?
Okay, that's a good question. So as I said, those regression lines are through the origin. That means zero. Okay, that makes sense biologically and physically, because when you have zero export, you should have zero salvage. That's why I use through origin regulation. Now, regarding your question for R-square value, statistically speaking, R-square value are called the regular R-square value. For this kind of regulation is meaningless because it's so high, usually greater than 0.5. Okay, so statistical book says don't use that. So that's why I did not put there. But there is a way we can calculate. It's called a modified R-square value, or confidence interval, or prediction interval for those regulations. But I have not done so. Yeah.
I guess, and I had a question on the previous slide, the ones you had the entrainment. Do they look similar if you normalize by, I'm not sure what is the right term, escapement or year class size?
I will get into that.
Okay.
Yeah, thank you. Yeah. So here's a winter run Chinook. And for spring run Chinook, very much similar. You can see the trend. Daily salvage increases with increasing water export. For juvenile steelhead, same trend. When you increase water export, salvage is increasing. Now get into OMR flow. You can see also the down trend. So when you have more negative OMR flow, that means more flow going to water export facilities, you would have more juvenile salvage, daily salvage. Okay, so for all three species, winter run, spring run, and steelhead, the same similar trends. So here we get into multiple variables to look at, because as I point out from one slide, there are many factors that would impact the fish movement. So in this case, I included the following variables: water export, CVP, SWP, or combined export, delta juvenile fish abundance, that's a daily abundance, also tide height, and the inflow, including Sacramento River flow, San Joaquin River flow, or combined flow, and then delta outflow. The next one is the San Joaquin River inflow to water export ratio, and the last one is OMR flow. And here listed are the number of models that select those I called most important variables, because I use stepwise statistical procedure. So the model would select what parameters or variables are important that must be included or should be included those regulation models. So in summary, you can see it's 3 species for winter run, spring run, and steelhead. The total models 32. That's the highest that selected water export as available. And next one is juvenile fish abundance in the delta. That's 29 models select this parameter or variable. And surprisingly, the tide height also was pretty high, 15 models selected. And the inflow. So inflow is very interesting. When you have high Sacramento River flow, and then salvage actually increases. I think that because Sacramento River bring down much larger salmon species individuals. And then for San Joaquin River flow, just to reverse, when you have high San Joaquin River flow, you would have lower salvage. I believe when you have high San Joaquin River flow that actually flush out the main channel, either through the main stem of San Joaquin River or interior delta, and goes to Chips Island. That makes sense. And lastly, those delta outflow, the ratio of OMR flow basically is a third criteria that indicates the fewer models select those variables. Now, I have to point out here why OMR flow listed as the last, the final one. I believe that is related to water export. The next slide shows how OMR flow strongly correlated to water export. So if we don't have head of Odo River barrier, that means flow can go through Odo River and then get into export facilities. You can see the strong correlation. The R-square value is 0.97. So basically, you can predict very well from water export and OMR flow. If we install head of Odo River barrier, then the equation changed some. Look at those coefficients here. When you have no barrier, and then about half of San Joaquin River flow goes to Odo River, that makes sense. Generally speaking, the split is about half and a half, 50%. When you install the barrier, and then basically it cuts off flow into Odo River, so it's only about 0.09. It's only about 10%. Remember, those barriers have culverts, so water still can go through some. It's about 10% here. Okay. And the last conclusion I said, juvenile survival rates are low in interior delta. So when fish go through interior delta, they have higher mortality. So here are major routes for fishes coming down from Sacramento River. The first one is the main stem, Sacramento River. And the second, the fish can go through Delta Cross Channel and then finally end up in Chips Island. The number 3 is the fish can go through Georgiana Slough and then finally end up in Chips Island. Number 4, the fish can go through North Delta from Sacramento River and get into South Delta because of reverse flow in South Delta, in Odo River and Middle River. And then those fish facilities salvage fish and transport from those fish facilities to sites near Chips Island. Okay, so here let's look at juvenile fish survival, juvenile fish migration routes in South Delta. This is the main stem, San Joaquin River. And then if a fish go second channel from Odo River and get into those water export facilities, and then you can have 2 routes. One is from CVP, transportation to Chips Island, and the second is from SWP to Chips Island. So here is a general summary from many, many studies for juvenile fish survival in North Delta and South Delta. So when you look at, in general, those data, in general, the coated white tacking studies, they have much higher survival rates. Those are early year studies. And then acoustic tech study indicates lower survival rates. Those are conducted in recent years. And the secondary, North Delta survival rates are much higher than South Delta, okay? Those are South Delta survival rates. So when you look at those rates, it's very depressing. It's only like 1% to 3% survival over there. So it's about 1 order or more magnitude different between the South Delta and the North Delta. And then if fish go through from North Delta to South Delta to water export facilities, the survival rates are very low too, very similar to South Delta. Okay, it's about 1% to 4%, depends on what facility you have. So conclusions. Number one, large quantities of juvenile salmonids are entrained to water export facilities. Number two, juvenile fish entrainment increases with increasing water export and juvenile abundance. Those are two major factors controlling fish salvage. Also shows an increasing trend as OMR flows become more negative. Number three, juvenile fish survival rate decreases from the main stem Sacramento River to interior North Delta to South Delta. Therefore, measures to reduce juvenile fish entrainment to interior North Delta and South Delta, for example, DCC gates closure and the restriction of OMR flow or water export, certainly will increase their overall delta survival. Thank you.
You may have time for one quick question, and we're going to take a break, just so you know.
I have a question. Li-Ming, you mentioned there were some wild fish as well as hatchery-raised salmonids that are released. Can you give us a sense of what that proportion is?
So it depends on what species. Okay, good. So it really depends upon what species we are talking about. For steelhead juveniles, okay, it's a very high percentage of hatchery fish origin. Yeah, I can give you exact number, but not on my mind now. I believe will be around from 70 to 90% for steelhead. And for spring run, also is pretty high, the percentage from hatchery. For winter run, it's not so high, but I do have those numbers I can provide you, yes.
Yeah, the reason I ask is because it goes back to Steve's question earlier about making some kind of adjustment of those. I guess you showed us, sorry, I don't have my graph up there. But if you could standardize some of the results that you presented in terms of the numbers of fish released, would be helpful to see variations in entrainment.
No, I believe I presented here for those charts, those regulation lines, those are only for wild. I exclude hatchery fish. Those are only wild fish, yes.
Okay.
Yeah. For salvage data, I present both wild and hatchery fish. Yeah.
Okay, so the salvage fish were the ones that I was thinking of. Thank you.
Okay, salvage fish, yes. Mm-hmm.
So those regressions got everyone's attention. I think this is on. Can you? I think it's interesting. You tried to relate daily values to daily values when there's a lot of things going on. Have you tried to aggregate it, on 5-day intervals, 10-day intervals? Because you also had a log scale on the y-axis as well as going through, well, 0, 1, but 0, 0. So have you looked at trying to get rid of some of that noise that's in there that's where they may be masking a stronger signal than may appear from there?
Yeah, Ken, that's a good question. We actually did some work already, especially, those data were challenged in the court. Okay. I think the bigger problem is that when we do average, particularly for export versus fish salvage, I strongly believe that would mask the variability. So when you have, for example, one day salvage is 100, the other day is only one fish salvage. Okay, so when you average even 5 day or 7 day, that would make the difference of variability disappear, and then makes the regulation much less strong. That's the issue. That's why the court document, particularly from Dr. Doriso, he used the yearly data or monthly data, and he concluded there is no correlation between salvage and water export. I think that makes sense. When you average, when you total the number of fish salvaged, then the variability is gone. So you mask those differences. Yeah.
Okay, I think it's time for a break. Let's take 10 minutes and come back in about 5 minutes.